Hi, welcome to Algebra 2 Common Core. Tonight we're going to learn a new definition for a parabola. This is called the locus definition of the parabola. You might remember that word locus from geometry last year. Looking at the locus definition of a parabola is the collection of all points that are equidistant from a fixed point, and that fixed point is called the focus, and a fixed line where the fixed line is called the directrix. So let's take a look at the graph that we're given in exercise number 1. We have the parabola y equals 1/4 x squared plus 1. Make sure that you pause the video so that you can write down that definition of a parabola in the box in your notes on page 24. So looking at this diagram, we see that the focus is labeled. We can see that the coordinates of the focus are the point 0, 2. So this point right here is the focus of the parabola. We also see the directrix labeled right here, and the directrix for this particular parabola happens to be exactly the x-axis. So I'm going to write that down. The directrix for this one is the line which is formed by the x-axis. So of course we know that the equation for that line is y equals 0. Now we're going to explore this idea of distance for a few minutes, looking at various points along the parabola. So first of all, let's look at the point 0, 1. This one is not identified, but I'm going to put a point right at that spot. That's 0, 1 right here. We would all know that point as the vertex of the parabola. So we're going to see if this vertex satisfies the definition of the parabola. We want to know how far is it from that point 0, 1 to the point, the focus, which is the ordered pair 0, 2. And if I measure, I see that those 2 points are just 1 unit apart. So therefore, this distance is 1 unit. Now I'm also going to measure from that very same point, 0, 1, to the directrix. And I see that that distance is also exactly 1 unit. So far our definition looks good. The vertex is part of our parabola, and the vertex is exactly the same distance from the focus as it is from the directrix. Let's move to a different point on our parabola, 2, 2. I see that I can pretty easily measure the distance from the focus to that point 2, 2, and that distance is 2 units away. I also want to measure the distance from the point 2, 2 down to the directrix. I would go that perpendicular distance right there, and I see that that distance is also 2. So the point 2, 2 also satisfies the definition of a parabola because it's the same distance between that point and the focus as it is from that point and the directrix. Now it gets a little bit more complicated when we have a point like the point 4, 5. When I look at the distance from 4, 5 to the focus, I see that this is actually a diagonal distance. Some of you may recall that we usually do that diagonal distance using either the distance formula or creating a right triangle and using the Pythagorean theorem. So if I create a right triangle, I see that the horizontal distance is 4. I see that the vertical distance is 3. So using the Pythagorean theorem, I can say that the distance squared is equal to 4 squared plus 3 squared. I could just as easily have used my distance formula being the square root of x2 minus x1 squared plus y2 minus y1 squared. So whichever way you feel more comfortable finding that distance. Doing it using the Pythagorean theorem, I get the distance squared is equal to 16 plus 9. So that tells me that the distance squared would be equal to 25. When I take the square root, the distance between the point 4, 5 and the focus is equal to 5. Now let's take a look at the distance from that point 45 down to my x-axis. Because I'm taking that perpendicular distance, I can just count the boxes, and I see that that distance is also 5. So the point 4, 5 is the same distance away from the focus as it is from the directrix. Now what I'd like you to do is pause the video and work on the last point yourself. In your notes, it's in the table. 6, 10 is the last point that we're going to look at. Find the distance from 610 over to the focus. Also find the distance from 610 down to the directrix and see if they match. You should see that whether you use the distance formula from 610 to 02, or you use the idea of the Pythagorean theorem with the right triangle, you should get that the distance is equal to 10. If I measure directly from that point 610 down to the directrix, counting these boxes, I got also that the distance was 10. So we want to use this idea of distance from any point on the parabola to the focus has to equal the distance from any point on the parabola to the directrix. So what we're going to do is label a random point on our parabola. Doesn't matter where the point is at all. So I'm going to say, let's go with this point right here, but it could have been anywhere on my parabola. I'm going to call that point x, y. It's a generic point. I'm going to find the distance from that point to the focus, and then I'm going to find the distance from that point down to the directrix. Again, in a general, generic form. So let's go ahead and calculate these two distances. First of all, I'm going to go from the point xy to the focus, which is 0, 2. So when I do that distance, I'm going to use my distance formula and say the square root of. Using my points, I'm going to say the difference of the x coordinates, so x minus 0 squared, plus the difference of the y coordinates, y minus 2 squared. On the other side of the equation, so I'm going to set these two things equal to each other, I want to go the distance from the point xy to the directrix. Now, since I'm measuring down, it's a vertical distance, so that distance is just going from the x-axis up to that point, which is just equal to whatever my y coordinate is. Think about that for a minute, how it's the y coordinate. Now, all I'm going to have to do is simplify this algebraically. So first of all, underneath the square root, I've got x minus 0 squared is just x, so I'm going to square that. When I square y minus 2, that gives me y squared minus 4y plus 4 equals the y on the right side. Now, of course, this means that I'm going to have to square both sides of the equation to eliminate the square root sign. So I now have x squared plus y squared minus 4y plus 4, because squaring a square root just eliminates the square root, on the right side equals y squared. Clearly, I can subtract y squared from both sides of the equation, so that cancels off the y squared and leaves me with x squared minus 4y plus 4 equals 0. Now I want to get my equation in this form right here, which means that I'm solving for the y. So to solve for y, I'm actually just going to move the y to the other side of the equation. So x squared plus 4 equals 4y. Go ahead and divide everything by that 4 to get y by itself. And another way of writing this equation is y equals 1/4 x squared plus 4 divided by 4, which is 1. So we're going to get very used to using this locus definition of the parabola, always setting the distance from any point on the parabola to the focus equal to the distance from a point on the parabola to the directrix. Let's go ahead and try exercise number 2, where we want to find the equation of a parabola whose focus is the point 0, 7, and whose directrix is the line y equals 3. So first of all, you can see that sometimes the directrix will be a horizontal or in fact a vertical line, and it doesn't have to be the x-axis or the y-axis. So I'm going to draw this in and I'm going to say, okay, I've got 1, 2, 3. Here is my horizontal line that is forming the directrix y equals 3. Keep counting, 4, 5, 6, 7. So this point right here is going to be the point that forms my focus. I'm going to mark it F for focus, 0, 7. Now we know that the parabola has to have the focus inside of it. And we know that the directrix has to be on the other side, on the outside of the parabola. So when I draw this parabola, the first point that I'm always going to put is the vertex, and that's going to be halfway between the focus and the directrix. And then I'm just going to sketch a parabola that includes that focus on the inside. Ooh, that's kind of a messy one, but that's what it would kind of look like. And then I want to use my locus definition in order to make this equation. So I'm going to set the distance from a generic point xy to 0, 7. So let's pretend my point x. Now let's go ahead and take a look at the work for this. So when I'm going the distance from xy to 0, 7, I set up the distance formula. So the square root of x minus 0 squared plus y minus 7 squared. On the right side, y minus 3 is just this distance right here. On the left side, I squared the y minus 7, and that gave me y squared minus 14y plus 49. And then since I've got this radical, I want to square both sides of the equation. So on the right side, that means that I'm squaring that binomial. Left side, x squared plus y squared minus 14y plus 49. On the right side, y squared minus 6y plus 9. So again, let's cancel the y squareds from both sides of the equation. And let's add 14y to both sides so that we now have x squared plus 49 equals 8y plus 9. Finishing off, I'm going to solve my equation for y, so let's subtract 9 from both sides of the equation. So 8y is equal to x squared plus 40. And then go ahead and divide both sides by 8. And I'm going to write this equation as y equals 1/8 x squared plus 40 divided by 8, which is 5. Let's do exercise number 3 together. So we want to sketch out the parabola whose focus is at the point 4, 1. So find that point. So I've got 4, 1 right about here. And I'm going to mark that F for focus. The directrix is the line y equals -3 this time, so I'm going to have to count down and say, okay, here is my directrix, y equals -3. Now I know that the vertex has to be the point halfway between the focus and the directrix. So if you count, it'd be easier if we had graph paper, but if we count this, I see that my vertex has to be located at the point 4, -1. Knowing that the parabola always opens so that the focus is inside of the parabola and the directrix is on the outside, my parabola looks like this. So I am going to set up a point x, y, and I'm going to take the distance from xy to that focus 4, 1. So let's do my distance formula. So the square root of x minus 4 squared plus y minus 1 squared is equal to, now let's be careful with this one. We want to go from this point xy all the way down to where my directrix is. So this distance from this point down to the x-axis, that's y. But then I've got to go an extra 3. So that total distance this time will be y plus 3. You can also think of it as the y coordinate minus the equation of the directrix, so y minus -3, which also gives me y plus 3. Now I'm going to go ahead and take a couple steps at once here, so I'm going to start by squaring both sides. So when I square both sides, that of course eliminates my radical. Can I go ahead and square those binomials underneath? So x squared minus 8x plus 16 plus y squared minus 2y plus 1 equals, on the right side, let's square that binomial, y squared plus 6y plus 9. Y squareds will cancel from both sides of the equation. So that tells me that I now have, getting my y's on one side of the equation, let's add 2y to both sides. And I think all at once I can subtract 9 from both sides. It doesn't matter where I subtract that 9 as long as I'm moving it to the left. So I now have x squared minus 8x, and that gives me a plus 8 when I combine all of the constants, equals 8y on the right. Now at this point we're going to divide each and every term by 8. So another way of writing my parabola would be y equals 1/8 x squared minus 1x plus 1. So you'll notice that we're now writing this equation for the parabola in standard form. If you need to, go back over this part of the video where we're going through this example and go step by step through it so that you're sure you see where each part of the equation comes from. I'd like you to try exercise number 4, so start by sketching it, and then use the locus definition to create the equation of the parabola described. Welcome back. Please check your work with the work that I've shown for exercise number 4. So we want to find the equation of the parabola that has a focus of -2, 4. So notice that I've plotted that right here at -2, 4. The directrix this time is y equals -6. So my parabola looks like this one right here, where the vertex is going to be at the point -2, -1. Halfway between the focus and the directrix. Plot a generic point xy somewhere on your parabola, and let's find the distance from xy over to the focus. Now clearly I have not drawn this picture to scale because this distance from the focus to the point is not the same as the distance from the point to the directrix. And for a parabola, those two distances must be equal. So setting up my distance formula, I got this. Setting up the distance from the point down to the directrix, I have to go y and then another 6. So y plus 6 is happening right there. On the right side, when I squared the y plus 6, that gave me y squared plus 12y plus 36. On the left side, I squared the square root and then squared the binomials underneath. In this case, what's happening is the y squareds are canceling, and I want to add 8y to both sides of the equation. So now on the right side, I've got 20y. I also want to subtract 36 from both sides of the equation. So on the left side, I've got x squared plus 4x minus 16. Lastly, let's finish off by dividing each and every term by 20. So I reduced my fractions, and I got the simplified equation for the parabola. Y equals 1/20 x squared plus 1/5 x minus 4/5. Now, not all of our parabolas will open up. So we're going to try the next exercise number 5, finding the equation of a parabola that has a vertical directrix. So notice the difference between my picture here. Find the equation of the parabola with a focus of 6, -2. So first of all, I'm going to start by plotting the focus, 6, -2. Secondly, I want to go to my directrix, which this time is an x equals equation. It's a vertical line. So it looks like this, x equals 2. Remembering that the focus always has to be inside the parabola, and the directrix always has to be outside the parabola, the vertex is going to be halfway between the two, so it'll be at the point 4, -2. So again, not exactly drawing to scale, but my parabola will open something like this time opening up to the right so that the focus is on the inside. Now I'm going to pick any point on my parabola, and I'm going to call it xy. This point, it doesn't matter where I put it at all. It could be anywhere on my parabola. It's just to give me a feel for those distances. So the first distance that I'm going to do is the distance from the point to the focus. So let's do the square root of x minus 6 squared plus y plus 2 squared. Now we need to do the distance from the parabola from xy over to the directrix. Now when you look at this distance, it's this direction right here. If I start all the way over here at 0 on the y-axis, this distance would be x. I don't want to start all the way over here at 0, I want to start at 2. So when I'm measuring that distance, I'm only going from here to here. So that distance that I've designated there is really x minus 2. Notice that I used to write that as a y when I had a horizontal directrix, but now that I have a vertical directrix, it's going to be an x distance. So I'm going to say x minus 2 is that distance. Let's square both sides of our equation. Squaring on the left and then squaring my binomials, I've got x squared minus 12x plus 36. Squaring the y binomial, y squared plus 4y plus 4. And on the right side, let's square that binomial, so x squared minus 4x plus 4. This time, when I look carefully, I see that I have an x term on both sides of my equation. So I'm going to cancel off those x terms, x squared. What that tells me is that I want to get my equation where the x is by itself this time, because this is a sideways parabola. So to do that, I'm going to add 12x to both sides of the equation. Going ahead and doing that, I now have 36 plus y squared plus 4y plus 4 equals 8x plus 4. Let's get the x by itself, so subtract 4 from both sides of the equation. So 8x is equal to y squared plus 4y plus 36. Finish it off by dividing both sides by 8, every term by 8. So I have the equation x is equal to 1/8 y squared plus 1/2 y plus, let's reduce that fraction by dividing the top and the bottom by 4, 9/2. So this is the equation of the parabola that we have drawn, the one with a focus of 6, -2 and a directrix x equals 2. We're going to do exercise 6 together in class tomorrow. What I'd like you to do is give it a try. Start by drawing the diagram first and setting up your distance equations on the left side and the right side. And then we'll finish it off from there in class tomorrow. We're going to also talk about a few of the examples of parabolas using focus and directrix, some real-world examples. So have a great night. Thanks for sticking with this pretty difficult algebra on this one. And if you need to go back over any parts of this video, please replay it and listen to the audio again. Have a great night. We'll see you next time.